Hi, and hi
Yeah,
everyone. So I joined myself with Praveen here, my co-author. Thank you for letting us into the conference, and yeah, I can proceed. So uh,
yeah.
we can
Hi
proceed,
everyone.
right? Yeah. Hi. So like I believe that we are all over the world. So let's say I'll say good morning and good afternoon, everyone. So it's an honor to be here presenting our research on tackling the big data challenges using the soft computing techniques. And let me introduce myself. I am Anil Kumar Jonnalagadda with over 17 years of experience as a data engineer, working at different organizations like Amazon, Google, and Meta. My work mainly focuses on developing the solutions for the data that is receiving on robotics, AI, and the neural networks for large-scale data applications. And I have completed my master's from US, and I completed my bachelor's in India. And my co-author Praveen, I would let him to introduce himself before I set the stage and proceed for the introduction.
Yeah, thanks. And hi everyone. This is Praveen Kumar Myakala. I am currently living in USA. I graduated from Indian as a Bachelor of Technology, and I'm recently completed after my 20 years of career, around 20 years of career, master's degree, and currently working on some research topics related to AI and ML area. Yeah, thanks for giving opportunity. We will continue on the topic. Anil, you can go ahead.
Yeah. So currently, the topic that we are talking about is the big data challenges using the soft computing techniques. So I'll be going over my presentation. Our topic that we chosen is because we are trying to explore how the techniques related to the fuzzy logic, the neural networks, or evolutionary algorithms that can help the some of the problems when we are working with the big data, such as uncertainty and some kind of you know um, unrealistic outputs when we are working in the real world data sets. Especially I would see those things when we are receiving the data from the robotic responses for any inputs, especially when I'm working at Amazon, it deals with the robots in the at the warehouses, and the immediate response that you want to have it. Sometimes there are some predictive and noisy responses that give causes the a damage. So how can we avoid it? That's kind of a thing that is what we were tried to overcome using this research is what we were tried it. And this study mainly highlights the pivotal role of some soft computing methods to unlock the true potential data related to the big data that we are in the currently. Like enabling the innovative solutions and driving these some meaningful advancements across the industries, whether it is e-commerce or the regular IT or anything related to that, basically. So coming to the motivation and the challenges of the big data, so I would say that um, we know that for
Professor,
any big data.
sorry to disturb you. And can you share your screen, Professor, and show me the
Okay.
PowerPoint? Yeah.
I didn't plan any PowerPoint actually, so I'm going through some documentation kind of a thing that I just myself. And just going through the my document that I submitted.
Yep. Okay. Okay.
So yeah. So uh, we know that the five whys that are very important for the big data, right? The volume, velocity, and the variety, veracity, and the value. So using those three, five V's, that we have the some kind of challenges with respect to the scalability, and whenever we design any big data application, like we need to have these in mind. And traditionally, if you build any applications or the algorithms around the big data, we will have these some problems actually to handle their size or the velocity with respect to the data streams that are incoming, especially in the real-time data world. So because of that part to overcome, especially the scalability, I will take the example with respect to the a healthcare system. And when we were trying to get the a different data, patient data across the multiple hospitals, I would say that traditional databases will have the some kind of performance issues, like when you want to process it in a scalable way. And with so for all these five V's, like that are having the currently issues, like we would like to improve our big data five V's using the soft computing that excels in handling the such complexity. So yeah, that's what we were planning to go and explain it. So I'm handing over to the Praveen for giving the a little introduction about the role of soft computing. And yeah.
Yeah, and the role of soft computing, we discussed it in a high level here, and like especially we, it's like completely different from hard computing. The soft computing tolerance impairments and uncertainty in the big data area. Especially the key techniques we discussed in the paper is fuzzy logic and neural networks and evolutionary algorithm. So the fuzzy logic actually handles imprecise and merge data with interpretatory decision make rules, and neural network handles with the learn patterns large in on the large data sets, such as fraud patterns in financial transactions. Evolutionary algorithm especially optimizes tasks like feature selection, clustering, and resource allocations. Then we have like hybrid systems for better accuracy in the soft computing, like neuro-fuzzy systems and evolutionary-fuzzy systems. The neuro-fuzzy system combines neural networks learning with fuzzy logic. Uh, at the same time, like evolutionary-fuzzy system uses evolutionary algorithm to fine-tune the fuzzy model for improved precision. So those topic we touched. Then why we felt like the soft computing works for big data, that it will handle heterogeneity, noise reduction, and high dimensional data better than the rigid or like harder computing traditional method. So what we understand after researching on this, the soft computing offers adaptability and interpretability and robustness, making it invaluable the importance to the big data. So we felt like soft computing may be helpful a lot in the area of big data. Uh, Yeah, that's what we analyzed and we covered in this thing. And we try to propose some framework which will use the soft computing techniques in a hybrid model, something like that. So we this is theoretical, mostly theoretical. There is no exact practical evidence or detailed practical evidence. So we did some basic experiments, but we thought this will be the best approach or best workflow for the handling big data issues in the soft using the soft computing. Especially, we divided this architecture into the framework architecture into five main parts. One is data pre-processing. The second step should be the feature extraction and selection. Then the third one is soft computing core, the core logic, which will have the fuzzy logic, neural network, and swarm intelligence for the processing, whatever is up for our system or maybe in a hybrid. And then the optimization, enhancing the resource allocation and work distribution is the fourth part. Then result aggregation. So we we plan like these five models will be very important in the proposed framework. So as I said, the model one will do data pre-processing, which will clean, normalize, and reduce the noise in the data. Example like removing outliers in the healthcare records, improve the prediction accuracy, or removing the outlier from the fraudulent banking transaction information. Then the second step, what we do is extracting and selectioning the feature, like reducing dimensionality using neural network or evolutionary algorithm. As I mentioned earlier, evolutionary algorithm we can use here, like an example that identifying the key sensor readings in IoT predictive maintenance systems. And then the third model, soft computing core, combines fuzzy logic, neural network, and swarm for processing, as I mentioned earlier. Then we jump into optimization, enhance the resource allocation and workload distribution part to make it perform better. Then once we done these steps, like integrating the output and actionable insights, we will find out for the business intelligence systems. So we can implement such a system, say like Spark, using the Spark to manage financial fraud detection pipelines. So we tried experiment using Apache Hadoop for distributed data storage and the TensorFlow for neural network training, then and the Spark for real-time processing. We used these type of tools to do the basic experiment, whatever we did during the when we are writing this paper. The strength we felt is the scalability, adaptability, and efficiency. So the scalability in perspective, the process terabytes of data effortlessly. So we tried with gigabytes of data, but not terabytes of data. But we can feel that it can easily handle the terabytes of data. We used some Kaggle data sets to do testing. So adaptability, like it works across the different domains because it handles a huge data. It can be applied to finance, healthcare, or IoT domains. And we felt like efficiency is a lot, like minimizing the resource usage. Whatever we ran the test data, we saw that it's using very less resources as we have very low capacity systems. Still we are able to run the process, and it's giving the better results. So what I want to conclude is this framework enables organizations to handle increasing the data complexity with precision and efficiency. Anil, you can take care. You can go ahead and
Sure.
continue with the next.
Yeah. Uh, the next topic that I would like to talk about is the experimental results and the applications. So, like Praveen mentioned that during our process of writing this research paper, like, we have done the some kind of testing on different domains with the test data that is available in the internet for finance, healthcare, and IoT. So for the healthcare, like, we have trained our models using the patient data for a disease diagnosis like cancer, and for IoT, we have taken the real-time data for industrial sensors related data, and when we running the different models without and with the soft computing and the fuzzy logic, we were seeing the 30% of improvement in the resource utilization, and a 20% increase in the throughput. And this reduced a significant reductions in the computational time as well. The both worker and master nodes are very happy during the our process. And like I mentioned that we have done this across the healthcare, IoT, and the finance related. In the finance, we have tried to get the some fraud detection in the credit card transactions kind of a thing using the hybrid neuro-fuzzy logic. That was helped us to process the almost like a huge data that with the very minimal setup that we had it. And with the results that we have seen it and mentioned previously, like, we were assuming and can confirm and conclude that the framework that Praveen previously demonstrated has the power of can drive the actionable insights in the diverse fields with the soft computing. So the traditional challenges that whatever we are facing it with respect to the big data can be easily overcome with this approach that we are thinking it. So moving to the conclusion and the future direction, like, I would say the summary for this a scalable framework, including the fuzzy logic and the neural networks and the algorithms, we can like, take the big data and set the stage for future innovation without compromising on the infrastructure a lot, actually. So we can define the lightweight AI models for the resource constrained environments where we thought like this patient or the fraud monitoring or such kind of, like, by industry, like I mentioned it in the past. And we can even implement the hybrid neuro-evolutionary systems also for increased accuracy. So yeah. And yeah, thank you for all of your time and attention on this paper. And I hope this presentation has shed some light on the exciting possibilities of using the soft computing for big data analytics. We're looking forward to hear your feedback and like, engaging in this discussion. Please feel free to ask any questions about the framework or the applications.